Hello, now I'm going to give an overview of Heron topology submission workflow. I hope it can help people to understand the code base. You may trace the code base with this workflow to understand the code better. So what's the workflow of Heron topology submission? We invoke the Heron CLI submit, and what will happen? First, we'll start a JVM process, submitter may, which is in the Heron scheduler called codebase folder. Then, this JVM process will pause and read from config and construct a config object. It contains all necessary information statically. Then, first step, we will validate the submit, whether it is valid or not. Mainly, currently, we will validate whether this topology has already exists, or whether you have the permission to submit topology. And second step, we will try to upload your packages, the topology packages. Here is where we use the iUploader. We will invoke iUploader's interface to do the uploading. Then it will return a packages URI. We will use all of this runtime generated information and construct a config called runtime, including your packages URL and other information. Now we are ready to submit a job because we can see that all are same head off. Then we will first set some states. For example, topology state, the execution state, which are defined in our protobuf. Then we will launch a topology. Here's a question: what does it mean to launch a topology? To launch a topology, we have two modes. One is trying to launch the scheduler as topology as a service. So in fact, launch topology, we just launch the scheduler and then let the scheduler to schedule the REST containers. If you choose to launch topology, make the scheduler as a service, then we'll launch the scheduler main, which is also in the scheduler core code base in some resource manager places. For example, Mesos. Or for example, local file scheduler. It will run in the local scheduler. It will run the scheduler as a separate process somewhere in the working directory. And then the scheduler will do. First, it will start a scheduler server because remember, we just mentioned earlier, the scheduler also needs to take care of the runtime requests from client and do some runtime management. For example, we start a container or others. So it needs a scheduler server, and then you're trying to start the REST containers, scheduled REST containers on that resource manager. For example, for local scheduler, you're trying to start the REST containers locally. For Yarn, you're trying to launch other Yarn containers. And another choice is to launch topology and launch the scheduler as a library. By saying use the scheduler as a library, we will invoke the iScheduler, which is implemented by users, by the operators. We'll invoke iScheduler interface directly as a library. So we will not run the scheduler main as a process somewhere anymore. We'll just invoke the interface directly. So in the submission workflow, both of them, you invoke the iScheduler on schedule, these methods. So these methods will take care of how to schedule the containers you need for this topology. As a service, it will be done in some remote server side. As a library, it will be invoked directly. For example, the Aurora scheduler is used as a library. So we'll invoke the Aurora scheduler on schedule directly and schedule the containers on Aurora side. So this is mainly the workflow of a topology submissions, and I hope it will help. That's all. Thank you.